I very much want to thank the organizers of this conference for inviting me. I'm very excited to be in Ohio and visit you all here. I want to talk about the importance of watersheds. Dean McFerrin set me up perfectly for this slide because this is the problem with nutrient overenrichment in water resources. And you all feed into two major basins, both Lake Erie and the Mississippi River. But we have these problems on the Atlantic coast. We have them in the Chesapeake Bay, in Tampa Bay, in the Neuse River Estuary. Nutrient overenrichment is a huge problem, and one of the major sources is agriculture. With that, we know that conservation practices work. We've been looking at conservation practices for over 40 years, and we can prove that they work. So the question becomes, why isn't our water quality better? And part of the reason, let me see if I can, is that we don't know whether or not they work at the watershed scale. And so what I want to talk about today is water quality protection at the watershed scale, but it's really quite complex. We did a study for NIFA, and I want to talk about this study because it really organizes a lot of the lessons we need to be thinking about. They funded 13 watershed projects across the country with the expectation that these projects would look at the relationship between conservation practice implementation and water quality change. To be part of this protocol, you had to compete in the RFP process, and you had to have land treatment and water quality data for a minimum of 5 to 10 years. There aren't many watersheds that have that amount of data. And most of these, in fact, all of these projects were in agricultural regions that were either crop production or pasture land. There were 4 questions that each of the 13 projects had to address, and I'm not going to go through these verbatim, you all can read, but basically, can we affect water quality at the watershed scale? Do conservation practices have similar attributes in reducing pollutants? What are the socioeconomic constraints of getting conservation practices on the ground? And last but not least, where is the best place to put these conservation practices in a watershed? Now, the 4th item really had to do with water quality modeling because experimentally this is almost impossible to do. So the successful projects were scattered across the country, which was ideal. We went from New York to Oregon, from Idaho to Georgia. And if you look at the pollutants of concern, the primary one was phosphorus, which I know you all are thinking about a lot. The second was sediment, and the third was nitrogen. But there were some watersheds where they were looking at all 3. And as these projects were coming to an end of their funding cycle, NIFA and NRCS funded a synthesis project. They said, okay, we have these individual results. What do these results mean? And that's where I come into the picture. I led a team that synthesized the information from these 13 watersheds and have been providing lessons learned. And so what I want to talk about today is ways that we can do a better job of protecting water quality at the watershed scale. So I'm just going to cut to the chase. What were the water quality results from these 13 watershed projects? What we found was that all of the projects that were successful had a lot of conservation practice implementation and good water quality monitoring design, critically important. However, there were other projects that had those attributes that did not show any water quality change. So that's also important. 3 of the projects had long-term monitoring. By long-term, I mean greater than 20 years. And so there was a project in Idaho looking at sediment, a project in Nebraska looking at groundwater nitrate concentrations, and Rock Creek here in Ohio, which was Heidelberg University's long-term data record, which were all showing positive results. Now, we're going to go back to the Ohio example because when we visited the Ohio CEAP project, it appeared to be a success story because they had been showing decreases in total phosphorus. But again, we'll come back to that. The other 3 projects that were able to show water quality change all used a paired watershed design. And 2 of the projects had been funded already by US EPA as part of their 319 National Monitoring Program project protocol. And so, again, the experimental designs that these watersheds used were critically important for showing this change. But let me just say, even those projects that were able to show reduction in nutrients or sediment never met their water quality goals. Okay, so that's also very important. So let's talk about some of the challenges in protecting water quality at the watershed scale. The arrow that you see there is all of the federally funded government projects that have looked at the relationship between water quality change and BMP conservation practice implementation. The longest, the Rural Clean Water Program project, ran for 15 years, and towards the end of this project, I actually helped the group that determined the lessons learned. The most recent project is the National Institute of Food Conservation Effects Assessment Project, which is what I'm talking about today. The thing that was absolutely disheartening to me, having worked on the Rural Clean Water Program project, is most of the lessons that we learned in Rural Clean Water Program project, we relearned in NIFA-CEAP. They had not been incorporated into federal and state agency programs that implement conservation practices. Now, some of them had been taken to heart by US EPA. None of them had been taken to heart by USDA, all right? And so if we're going to keep funding these kinds of projects and we're going to be learning things, then federal and state agencies really need to incorporate those lessons into the way they do conservation planning. It's critical, or we're not going to change the curve. So that's the overriding lesson we came out with. But now I really want to switch gears. And I want to talk about what would make conservation practice implementation better. This is the area that I enjoy the most because this is the area I work in. In order to change water quality, we have to do it at the watershed scale. The watershed integrates all of the agricultural activities and all of the climate signal. Unfortunately, what happens is that we're not planning at the watershed scale. We need to make sure we have water quality data, maybe modeling data, and we need to stop doing random acts of conservation. How many of you have heard about random acts of conservation? Any of you? A few of you? Well, that wasn't something I have made up. It was something I heard an NRCS employee talk about 2 months ago, okay? So we can't do that. So we have to start talking about conservation as an intentional act, all right? We have to have intentional planning. All right, once we get to intentional planning, then we have to think about intentional implementation. Generally what happens is you figure out what kind of conservation practice you're going to use, and then you put it in your watershed. It won't affect the curve. You have to figure out what is your pollutant of concern, where is it coming from, and how is it being transferred out of your watershed. Let me give you some examples. Where is the pollution coming from? A number of the projects were concerned about sediment. They thought it was in their uplands. They were treating it with conservation tillage, great tool, and then they got into their watersheds to find out that 75% of the sediment was being delivered from their streams. But they were not affecting their streams. They were not putting BMPs on their streams. The other issue has to do with hydrology. How is that nutrient or sediment being transferred? In Indiana, they were concerned about nitrate leaching through the soil into the tile drains, just like you all are here. So what was the practice they were using? Conservation tillage. Conservation tillage is a great tool, but it does not reduce nitrogen loading through the soil and into tile drains. As a matter of fact, it may actually increase it. So they weren't matching the conservation practice to the hydrology of the system. So that's really critical. Then there are these other things that have to do with how conservation practices actually work. And I want to give some examples. So a conservation practice may not work the way you think it's going to work. In Missouri, they were using a lot of conservation tillage. They were excited. It was going to reduce their herbicide losses. It was going to reduce their nutrient runoff. What they found is that because of their soils, they actually increased herbicide runoff and they increased nutrient runoff. And what they suggested is they needed to start tilling lightly, okay? Because their soil types, conservation tillage doesn't work. Conservation practices can have the same conservation practice can affect different pollutants differently. So in a couple of the watersheds where they were looking at terraces, grassed waterways, and drains into the terrace, great tool for reducing sediment, great tool for reducing total phosphorus, increased nitrate loading. Okay, so the same BMP system had different effects. And the last one was you can change a conservation system and it'll affect your pollutant delivery different. And the example I've always given here is Ohio. But I want to talk a little bit about that more with you all since you're in Ohio. So there may be these trade-offs in conservation practices. This is data from Heidelberg University. Pete Richards was really gracious with us, and he's really gracious with everyone considering his data. And when we were talking to him and we visited that Rock Creek watershed, he said, you know, I've seen that total phosphorus is being reduced. We've had great success. Lake Erie is being cleaned up. He said, but I'm really concerned about this soluble phosphorus trend. And he said, we can't figure out where it's coming from. He said, maybe it's because the soil is stratified with phosphorus. Well, we looked at their soil test data and we didn't see that. And so what we concluded after talking to some farmers was they had shifted nutrient management. Instead of spring application of phosphorus, they were going to fall application. Instead of mixing it into the soil, they were going to surface application because of all the conservation tillage that had been put into that watershed. And instead of putting on a little bit every year, they were putting on a lot at the same time to cover several years' worth of cropping system. And then we had a team member said, whoops, you got another problem in this watershed. They've been adding tile drains like crazy. So I just want to brag on you guys because some of the most interesting research on phosphorus movement is coming out of this state. Because we're finally seeing that phosphorus does move. And phosphorus in conservation tillage that has nice macropores can move through the soil into tile drains. And what we're seeing is a lot of soluble and total phosphorus moving. And this is from research that's been done by ARS and other folks in this state. So we know that the signal is changing based on, in part, these tile drains. But Doug Smith also just added like 25 factors that has increased soluble phosphorus loading in the Lake Erie watershed. So we have to think more seriously about how our conservation practices work, and we can't just blindly say, okay, conservation tillage is the tool. The next thing we need to think about in this intentional conservation planning is looking at getting the biggest bang for the buck. Critical source area, where are most of your pollutants coming from? We want to put our practices in those areas. 3 of the projects, Utah, Kansas, Missouri, all used different techniques, looked at their critical source areas, and found out that 75% of the conservation practices were not in the critical source area. If you have limited funds, you want to make sure they're getting into those critical source areas, or you're not going to affect water quality. So we're not doing that. However, if you're in a tile-drained watershed, that whole watershed may be a critical source area because of the way your nutrients are moving. We put on conservation practices and then we walk away and we assume farmers keep using them. We need to be really careful about those assumptions and keep working with our farmers. The project in Utah did a great study. There had been a watershed program there about 15 years prior to the NIFA-CEAP project. They put a lot of BMPs on the ground. They did a survey to see what they had done and what practices were being used. Most of the management practices, like nutrient management, were no longer being used. Some of the structural practices were being used, but many of the practices weren't. So if you're going to affect water quality, you're going to have those practices in the ground for perpetuity. Human dimensions is critical. I think it may be the most important thing when it comes to affecting water quality change. Many of the projects did socioeconomic surveys. We did our own key informant surveys with every single watershed we talked to, lots of different stakeholders, including farmers. I could give you an hour talk. I'm sure you're grateful that you don't have more than about 2 minutes right here, but we found many, many factors that affect farmer implementation of conservation practices. I've outlined the ones that we think are particularly important in yellow. Although economics is critically important, we found that ease of management in using these practices may be even more important. It may trump economics. Farmers can see soil running off their land, they can't see nutrients, and structural practices are way easier for farmers to use than management practices. Economic incentives are really critical. The two conservation practices that farmers hated the most were riparian buffers and nutrient management. Okay? Both of those are really critical to protecting water quality. Buffers take land out of production. That affects the farmer's bottom line. But there's even a more kind of insidious thing that may be happening with conservation buffers. We talked to a farmer in Ohio. He was renting land from another farmer. The farmer that he was renting the land from put a riparian buffer in. It took enough land out of production that the farmer that was renting the land no longer wanted to rent that land. And so the farmer that owned the land had a double whammy. It took land out of production, and he no longer had a rental agreement. So economics are important. Outreach. I would be embarrassed if I didn't talk about this. I have a 90% extension appointment, and so we know that outreach can be really important, but there are a couple things I want to say. The only watersheds where we saw that outreach made a difference was where they had dedicated extension specialists that did nothing but work with small groups of farmers on one issue, or dedicated soil and water conservation people. And that funding always came from grants. It wasn't just part of the extension agent's duties. The other thing that we found by talking to farmers and key stakeholders in every single watershed is that the level of support for outreach has dramatically declined as our budgets have been stressed. So there just aren't as many people in the watersheds as there used to be, and this is going to affect outcomes. One of the things that was really clear is that getting conservation practices on the land is both technical and it also involves people. And it's really complex because a farmer may have completely different reasons for putting in one conservation practice as another. It is a multi-dimensional thought process they go through. And so we as agency personnel need to be much more flexible and much more thoughtful as we work with our producers to get them to implement these conservation practices in the right place. So that's it for land treatment. This is kind of a bird's eye overview. I want to give a couple slides on monitoring and then one slide on modeling. So for those of you that know Pete Richards from Heidelberg University, he was the one that got the dedicated funding for that really long-term data set that you all have in Ohio, which is really critical to helping solve this problem. I have been misinterpreted, so I want to be really clear with this slide. It's not that we think that water quality monitoring isn't important. We do. It's just that if your intent is to show the relationship between conservation practice, implementation, and water quality change at a watershed scale, we don't think there are many projects that should be doing that. And the reason is that it's really, really expensive, it's really, really complex, and it takes a dedicated staff that know what they're doing. Our concern is that projects that try and do this, if they don't show water quality change, people will say conservation practices don't work. We shouldn't be using them. So it really takes a lot of careful consideration to do this well. And this is from Pete's shack in the middle of winter, just showing some of the difficulties in monitoring. But if you are going to monitor, and clearly there are projects that should be monitoring, we really suggest a paired watershed design where you monitor 2 watersheds close to each other that have similarities for about 3 years. Then you treat one of the watersheds, you monitor for another 3 years to show if the conservation practices are effective. This is the shortest term monitoring you can do to show a difference. And it's the monitoring design that EPA really suggests if you want to show water quality change. So we, again, are suggesting this one. Now, when you do water quality monitoring, if you want to show that it's made a difference because of conservation practices, you need land treatment data. And you need it at the same temporal and spatial scale as your water quality data. And I will tell you that as challenging as monitoring is, obtaining land use information is really impossible. Well, not impossible, really difficult. Trying to find out how much fertilizer every farmer in your watershed puts on, when they put it on, how they put it on, what kind of tillage they're doing, what are their cropping systems, that is really hard information to get. But it's critical to show these paired relationships. The other thing is change doesn't happen. I work in regulated river basins and watersheds in North Carolina that are impacted by nutrients. This is the Neuse River Estuary that I'm showing you its data. And the reason I want to show you this slide is to show you how difficult it can be to see a change in signal. So at about this time period, our state legislators said, because of massive fish kills, we are going to protect water quality. Everybody, point source, non-point source, has to reduce nitrogen by 30%. And so we all got really busy and started doing our work, and we were really excited because we started seeing nitrate, which is in purple, drop, total nitrogen in green drop, TKN, which is in blue, drop, and it was like, wow, we've done it. You know, we've implemented these practices and we're on our way to success, because here was the target goal. And then all of a sudden something happened and we started getting an increase in total Keldol nitrogen, an increase in total nitrogen, and we're back to where we were. And we have no idea why, okay? So even though wastewater treatment plants have reduced their nitrogen loading by close to 50%, and ag has reduced their nitrogen loading by at least 30%, we still don't understand this system. So it's really complex and it can take a long time, 20, 50 years for this lag time to show up in changes in water quality. Okay, a couple last thoughts. First of all, this is the last one I want to talk about relative to the NIFA-CEAP is modeling. Modeling is really hard. You need to make sure you use the right model. The Rock Creek project in Ohio, the NIFA-CEAP project, selected the wrong water quality modeling, and so they weren't able to use it. So you have to select the right model. You need somebody that really understands models. And then after you've run your model, step back and see if it passes the smell test, right? Because it's a model, all right? So that's really important too. All right, so at this point, I want to wrap up and give you some overall impressions that we had of this NIFA-CEAP work that we did. It appeared to us that for the most part, many watersheds, not all, many watersheds were doing a really good job of controlling erosion from their uplands, and that the problem is in the streams or the stream banks, and so we need to start looking at those. However, a cautionary tale is if our water signal, if the intensity and duration of our rainfall shifts, we may start seeing more sediment coming from our uplands. But what I really want to focus on, because it's my interest and I think it's your interest, is nutrients. And I think the nutrient challenge is going to be really difficult for a number of reasons. And this is partly we derive this from the NIFA-CEAP, partly this is from my own experiences. The first thing is that farmers cannot see nutrients leaving their fields. So it's harder for them to think about controlling nutrients than sediment. Management is really hard for farmers. So nutrient management is more difficult than getting a terrace on their land. Farmers use nutrients as insurance. We know that. We talk to a lot of farmers. That's what they were telling us. I work with a lot of farmers. So they don't see all the time the benefit, the necessary benefit of reducing their nutrients. A lot of times when we're working with farmers, we talk about this practice and that practice. We are never going to control nutrients unless we use a suite of practices. We need to use nutrient management, something that controls the nitrogen or phosphorus when it's being transferred, and then something in the water, such as a wetland, to help control nutrients. We've got to stop these one-off conservation practices. The year I put this slide together, it was a number of years ago, and it never got cold in the Midwest. Do you guys remember that winter? It was kind of warm all winter long. The farmers had just made a ton of money because commodity prices were up, and they put tile drains in like crazy. They changed the hydrology, and we couldn't even begin to get enough conservation practices on the ground to affect nutrients that were leaving through this changed hydrology. So tile drains are really quite a big, important piece of the puzzle. There were a lot of marginal lands that were pulled out, lands that had been in Conservation Reserve Program. The project in Iowa saw a 1,200% increase in nitrogen when they went from CRP land into corn and soybeans. So just think about that. When the lands were transformed, nutrients left. And last but not least, if in fact the climate is changing, so there's more intensity and a higher duration of rainfall in the spring, it may very well affect our nutrient losses. So we have a lot of work ahead of us, but I don't want to leave this presentation seeming like gloom and doom. But if we're going to control nutrients, primarily I'm talking about nutrients and sediment too, we as agency personnel cannot do it alone. It's also going to take agribusiness really getting engaged. So for instance, if a company lays tile drains, they also need to be engaged with water control structures. The folks that provide nutrients to farmers really need to make sure that the 4 Rs are being followed. So we need business and industry to be real partners in fixing this problem. We need the help from the farmers too, and then we all need to be vigilant in using intentional conservation at the watershed scale. And if we follow those steps over the long term, we can affect water quality, or I believe we can at the watershed scale. We produced a book from this work. We have fact sheets. We had webinar with EPA. We have a lot of resources available to folks from this work. And last but not least, I would be remiss if I didn't thank all the watershed partners we had that allowed us to come into their watersheds and collect this information, our funding sources. And I had this amazing team from Colorado State, University of Arkansas, Penn State, and NC State. This team was phenomenal, and we couldn't have done the work without this team approach. And last but not least, I'll take questions if there are any.